Hello there, Mr. Sutton here, bringing you this Pre-Cal Honors 5-8 lesson on simple trigonometric equations. In this one, we will be solving these types of trig equations, and as a real-life application, we're going to determine when a school will be a certain temperature. As a warm-up to get us thinking about trig equations, see if you can find this angle here in degrees for the given right triangle. All right, let's see how that went. So since I have a right triangle, we're going to use SOHCAHTOA. Specifically, since I have the opposite side and the hypotenuse, I'm going to use sine. So we have sine equals opposite over hypotenuse, which in this case means 0.5 over 1. So we essentially have sine of theta equals 0.5. Now how do we get theta? Well, we have to use sine inverse, this little sign with a negative 1 that's not really an exponent. And we can't just do that to one side, we have to do it to both sides. On the left side, sine inverse and sine cancel out, leaving us with just theta. On the right side, we get, well, let's use the calculator to figure this out. So you might remember to do this, we have to do second and then the trig function, sine in this case, and that gives us, notice, sine inverse. Now we put 0.5 in there, and I'm in degrees mode. Press enter, and I get 30 degrees. Cool. The concept you've been using all along with SOHCAHTOA to find missing angles is the concept of an inverse or arc trig function, such as cosine inverse, sine inverse, or tan inverse. These are functions that take an x, y, or slope value, depending on which one of these you use, and I wrote them in order here, and they'll give you back the original angle that would have produced that x, y, or slope value. Seems simple enough, it's just a reverse lookup. The trouble is, although there are usually two angles with the same x, y, or slope value on the unit circle, the calculator can only give us one. Now that's not an issue if you're just finding angles in right triangles because you're limited between 0 and 90 degrees. You're in the first quadrant. But if you start involving quadrants 2, 3, and 4, this is an issue. You're not going to be able to find all the angles just by using the calculator. So as a workaround, what we'll be doing today, we're going to use the calculator's value along with reference angles to get the angles that we want. Let's start doing that. Now that we have a basic idea of what's going on, let's do a full example to see how it all plays out. Here I'm trying to find the angles between 0 and 360, which is usually where we're looking, that solve this equation. We're going to start, and we'll do the whole example here together, and then you can try one on your own. We're going to start by isolating the trig expression. In this case, we want to get tan of theta all by itself so that we can inverse tan it later on. So to do that, subtract 1, divide by 2. I'm basically just doing normal algebra and pretending that tan of theta is something like an x or a y. All right, now that we've got that by itself, we need to figure out which quadrants we're looking for our answers in. On most of these problems, you're going to end up with two answers. To figure out which two quadrants they're in, I'm going to use the sign of the trig function to determine the two quadrants that theta is going to be in. So in this case, tan has a negative value, negative 1/2. So I'm basically asking which two quadrants give me a negative tangent, which is to say, where is the slope of my angle going to be negative? That's going to happen in quadrant 2, where you have a negative sloping angle as you move down and to the right, and also quadrant 4 has negative tans. So whatever value I get when I figure out theta from the calculator, I'm actually going to turn it into something in quadrants 2 and 4. All right, we need to actually use the calculator now. So this is where we use inverse trig to get a theta. In this one, we're going to do inverse tan of negative 1/2. Let's use the calculator for that. So here we go. I did second tan, and then I used my fancy fraction, alpha y equals, to get my fraction here. That gives me negative 26.6 degrees. And again, this is just the starting point. This is not our final answer. It's not even between 0 and 360, so it's not even any of our answers. But it's a starting point. We're going to turn it into something useful by finding a reference angle from what we just got. Reference angle in this case is just going to be 26.6 degrees. That's how far negative 26.6 is from the x-axis. And now we're going to use that reference angle to find the angles in the correct two quadrants, which we already figured out was quadrants 2 and 4. So to get a quadrant 2 angle out of 26.6, I have to start at 180 and go backwards 26.6, so 180 minus 26.6. That's going to be, let's see, 153.4 degrees. You could do it on a calculator just to verify it. And now I've already mapped out where I'm going for my next one, quadrant 4. This is why I like to do this in the beginning here. In quadrant 4, we want to go 26.6 degrees from the 360 end of the x-axis. So 360 minus 26.6, which is 333.4 degrees. So you might be wondering, do we always get two answers on these problems? Most of the time, yes. For most slopes, x values and y values, there's going to be two angles that give you those on the unit circle. The exception, so usually you get two answers, but the exception is if you have sine or cosine of -1 or 1. There's only one place where the sine is -1. It's at the bottom of the unit circle. Same with +1. There's only one place where cosine is +1. It's on the right side of the unit circle. Same thing with cosine that equals -1. So if you have one of these four cases, there's a single answer. Otherwise, expect two answers. For our next example, we'll do a real-life application. The temperature at a school can be modeled by the following graph and the equation that goes with it, where x is the time since school started and y is the temperature. So we see temperature starts at 75, goes down to about 65, and then the heat kicks on and it goes back up again. So what we want to know is how long after school starts, essentially at what angles, if we want to think about it that way, is the temperature a comfortable 68 degrees Fahrenheit or whatever. So we're essentially asking you to solve this equation between 0 and 360. Pause the video and see how far you can get. All right, so following the steps on our last example, we have to isolate our trig function, cosine in this case. So we subtract 70 from both sides and then divide by 5. That's -2/5 that cosine equals. And let's map out where we're going to look for our answers. Since cosine is negative in this problem, that's x values that are negative. That means we are on the left side of the unit circle in quadrants 2 and 3. Let's do inverse cosine now to get a value for x. Let's do the calculator. So here we go. Second cosine, plugging in that fraction, gives us 113.6 degrees. Now again, we want to get a reference angle out of this so that we can get quadrant 2 and 3 answers. So we're going to do 180 minus 113.6. Let's do that on the calculator. And that comes out to 66.4 degrees. So there's our reference angle. Now this may not be actually one of our answers. We don't know. We have to look back at our quadrants. We wanted a quadrant 2 answer, for example. So you could do 180 minus 66.4, or you could realize this 113.6 is already your quadrant 2 answer. Sometimes you actually get one of the answers right off the bat from the calculator. It's kind of hit or miss. We also need a quadrant 3 answer, though. Our calculator did not give us that. So we need to do 180 plus the reference angle of 66.4, which will be 246.4 degrees. For this next example, we're throwing a few curveballs at you to get you ready for anything. For one thing, your answer, if you look up here, now needs to be in radians. So you either need to do the whole problem in radians, which is kind of tricky, or my strategy, just solve this thing in degrees and then convert to radians at the very end. But we're not even there yet, because right away we see that we have this cosecant going on. There's no inverse cosecant button on the calculator, so how do we deal with this? Well, for secant, cosecant, and cotan, a good strategy on those is just to flip both sides of your equation to get one of the original 3 trig functions. So in this case, for example, we could rewrite this as 1 over sine of theta equals 14. And then if I flip both sides of the equation, I have sine of theta equals 1 over 14. Now, I usually don't show this step in the middle. I usually go straight from here down to here. In any case, pause the video and see if you can take it the rest of the way now. All right, so hopefully you started by figuring out which quadrants you're supposed to get answers in. Since sine is positive here, that means we're going to be above the x-axis, so quadrants 1 and 2. Let's go ahead and take the inverse sine of 1 over 14 now. So here we go. And again, even though our answer has to be in radians eventually, I'm doing this in degrees. So my answer here is 4.1 degrees. All right. And that actually is a quadrant 1 angle, but we'll convert that later on. Let's go ahead now, and we actually have a reference angle already too. So this is actually a very nice answer to get right off the bat. Let's use that reference angle to get both of our answers. Quadrant 1, again, is just 4.1 degrees. We already got that. Quadrant 2, we need to do 180 minus 4.1, which is going to be 175.9 degrees. And we're almost there. At this point, we're going to convert to radians. And remember, we have to multiply by pi over 180 degrees to do that. Only now we're just going to get a decimal out of it. It's not going to be an exact answer with pi. So 4.1 degrees times pi over 180. Let's do that on the calculator. So doing that on the calculator, I end up with about 0.07. They said nearest hundredth, so we're not going to do more than that. And let's do the same thing with 175.9 now. Plugging that in, we end up with 3.07. So those are our two answers now in radians. This concludes our first round of trig equations. Till next time, Mr. Sutton signing off.